Alright, video here, last couple of videos about eddy current. This one, we wanted to show you about the ability of the scope to determine conductivity in a percentage. Before, we've shown you just what the signals look like and how we can kind of decipher percentage of conductivity by the signals. We're going to use a low frequency probe here, a 60 kilohertz conductivity probe, and it's going to give us conductivity in an actual value and then liftoff in a value. So this says, the procedure basically says this: take your low frequency probe, okay, which we've already hooked it up. Let's just make sure, okay, we unhook it. It goes to regular screen, hook it back up. We've got basically conductivity and liftoff, and we're going to calibrate this to say what we want. Okay, so we're putting in a capture mode of press or repress. That means we have to push the button in order for it to take it. We're going to put in our cal point 1 as a low value. Okay, we're going to use lead. We have lead here of 8.1%. So we're going to take this down. This is percentage conductivity. 8.1, too far, percent. Okay, so I put the probe on the 8.1%. Let's scoot this closer so we can see. This is lead, this is copper over here. So here's my low conductivity. I'm going to push save. Okay, it saved it. Now it says cal point 2. We're going to run it up to 100. And it's actually 100.2. Okay, so put it on there, hit the save. It saved it. Okay, now it says cal point 3. We're using the same conductivity, but we want 4 thousandths worth of thickness or liftoff between that and the probe. So I just got two little shim stalks here to give me some lift off. I just put it over the top of that lead, put my probe down on there, hit the save button, it saves it. Now it says cal point 4, 100.2. Darn it, if I can get it where it needs to be sitting. There we go. Alright, well, I thought so. There it is. Put it down on there, hit save again. It says cal valid. If we turn this to continuous, we're 99.91%, right at 4 mils. Okay, there it is. Came right back to where needed. 100.05, 100.32. This is doing continuous measurement. So if we lift off, there's nothing. Come over here, 8%. Okay, that's close enough. Lift off 0 mils. So let's put a sheet that is 2 thousandths, or sorry, this is 5 thousandths thick. Let's put a 5 thousandths thick sheet on it. Actually, let's go over here. Let's just touch this. Okay. Roughly 30% conductivity. We got 0 mil liftoff. Let's put a 5 thousandths thick sheet on it. Okay. That's pretty close. 4.7 mils. This is 5 mils thick, 5 thousandths thick. I'd have to say that's close enough that we could deal with that. Okay. 29.46, 29.62, 0 mils, we put it on there. 29.3, 29.4, that's right where we were measuring before. And now we've got 4 mils thickness. So we've got some tape here. Same kind of thing, we put that on there. Okay, we're right at 29.4. Tape's about the same thickness, 4.5 mils, 4.5 thousandths or so. So we can just test something else here. We've got our thinning reference standard that we had before. We'll see how much difference we can get here. 42% conductivity. Here in the middle we've still got 42. Here on the end we're down to, you saw it shift down to about 5 there. Okay, so we're not close enough to the thickness. It dropped a little bit, but not much. Okay, same thing. We get clear over here on the end. About 42. Okay, what happens is it calculates the thickness. It knows that it's relatively thin, and it's got to compensate for that change. Okay, there's our 41. Okay, 41 again. So, just taking a look back at these same things. So that's 8, that's lead. Let's go in the middle. This says 29.3. Okay, we're about 1% off. That's not horrible. Okay, about the same. This says about 45. We're about 1.5% off there. We calibrated to the lead, 8.1. We calibrated to the aluminum, or sorry, copper. There we are, 100.1. Okay, and it's a continuous thing, so it's always measuring as well. So let's just pick something different here. Let's just get a piece that we've used a while back. We've got this piece. Let's just test its conductivity. Now 43% IACS. Let's put some shim stock down on it. About 10 thousandths thick. Same conductivity. So, easy enough. That's just a simple calibration, and this calibration is done a lot for hardness and conductivity testing of heat-treated aluminums and stuff like that, knowing the fact that when aluminum comes back from a heat treat, it's going to have a specific conductivity. So, we'll take something like this, set it up, we've got conductivity, we've got liftoff, we can slap this probe right down on that piece and know right off the bat, alright, it is 29, almost 30% conductivity. Oops, that's on a crack. That's not going to do us very good. It's almost 30% conductivity. Okay, now had it come back and it was 12% conductivity, we would know that it had been misheat treated or incorrectly heat treated, and we would have to go back and reheat treat it or try and do something different to get that conductivity back up. So, something to think about there. Easy way to tell conductivity and liftoff. Commonly used again to test for temper verification, hardness verification, things like that. So, questions about that, feel free to email me or call me, and we will get you straightened out.